The standard here is ARCH.HSA.SSE.B.3.8.5a. The learning target is I can solve quadratic equations by producing an equivalent form. A quadratic equation always has a term raised to the second power. So for example, a squared plus 15a equals 0. To solve the quadratic equation, you're going to find a. So first we factor out an a. We see that there's an a in each term, so we put it outside the parentheses, and then whatever is left as can be placed inside parentheses. So if we factor out an a from the a squared, a times a would give us a squared, and then a times 15 would give us 15a. So we factored out an a in this case. So now to solve for a, we set each term equal to 0. So if the term is outside the parentheses, we also set that equal to 0. Then we set a plus 15 equal to 0. Because when one term is multiplied by the other and it equals 0, then one of these terms has to be 0. Or can be 0. So we are looking for the possibility in each case. So either a equals 0 or a plus 15 equals 0. Now, if we want to solve for a, we're going to use the subtraction property and eliminate the 15 to isolate the a. So we subtract it on the left side. For a balanced equation, we subtract it on the right side. So this is eliminated, and we're left with a, and then 0 minus 15 is negative 15. So the solution, we say either a equals 0, which we already had that because it was alone here, or a equals negative 15. So when we define quadratic equation, we say it is an equation whose highest exponent is 2. In standard form, it appears like this, a being some coefficient of x squared, plus b is a coefficient of x, plus c is a constant equals 0, even if the constant is 0. This value cannot be 0, or it wouldn't be a quadratic equation anymore. A and b are called coefficients, where c is a number called a constant. On a graph, a quadratic function looks like a curve, never a line. And that completes this tutorial.